Hello everyone, welcome to my channel. Um, in this channel, we'll be talking about fraud analytics, and this is first of many series I'll be hosting. And I know you came here to study and to learn something, but I hope you stick around for the jokes. In this channel, we'll be talking about cutting edge research in the field of data science. And today's video is the research paper, a comprehensive survey of data mining based fraud detection research by Clifton Kua. The paper captures a decade worth of research in the field of digital fraud domain. And in this paper, the author talks about many cool things such as who are white collar criminals, how do we apply data mining to fraud detection, how do we measure if a analysis is correct, and who who will talk about and we will talk about fraud detection techniques in different industries. Um, So let's get started. The two main objectives of this paper is assimilating all the fraud detection fraud database till that exists at the time when this paper was published, and the second was to find areas which are similar where fraud detection technique can be applied, such as money laundering and spam detection. And these techniques are also discussed in this paper. So let's begin. At first we look at the types of fraudsters. They are, broadly speaking, we have internal fraud and the external fraud. The internal fraud can be managers or employees, and an external fraud is by criminals or organized criminal syndicates. There are companies which have millions of clients, and manually checking all the transactions is not feasible, especially in the kind of world we're living today. Many companies have to process so many applications, so many transactions that manually checking all these transactions is not feasible. So we need smart technology, smart methods. So that's where machine learning and cloud computing comes together, where we can process a large amount of transaction in the real time. So that has given way to fraud detection at a higher scale. And fraud detection is a tricky business because the fraudsters are always changing their modus operandi. It's also the mode of operation. And modus operandi is a funny word because like we should use it more in our daily lives. Like, what is your modus operandi to make that recipe? I mean, kidding. But so one of the most popular techniques in fraud detection is anomaly detection, and which is figuring out patterns which are different from the usual customer behavior. Another way you can look at fraud is identity theft or stolen credit card, and transaction fraud, which is the account takeover. Now let's talk about data, how data fits into this kind of categories. With different organizations, we have different data fields. In telecom, you can look at who the person calls, and how long was the call duration, what is the country of origin, what was the destination. In credit card fraud, we look at the amount that was transferred, where the shopping occurred, and at what time the shopping occurred. And we can also look at other indicators such as how many purchases were made in a short period of time, how far the shopper was from the store, and so on and so forth. And these are some good indicators which let us to know if a transaction is legit or not. Now, coming to the ways we can detect a fraud, there are various ways. There are supervised, unsupervised, semi-supervised methods to detect and identify fraud. So let's start and look at some supervised ways of looking and identify data. So, but before we get into that, let's talk about one. There could be uh, other data structures which might be useful in detecting fraud. So there can be unstructured data in form of email data, which could be used where feature generation or feature selection can be used, and text mining can be done to uh, identify if a fraud is related to it. That's my sister. Don't mind her. So How do we measure if a model is doing well and if we are correctly identifying fraud or not? So to do that, we basically look at the monetary value saved and the amount of profit we have generated, which are according to the policies we have set up. And in fraud, it's more important to reduce false negative because that might lead to a higher loss as compared to a false positive, where we might be blocking a customer from taking plan, which might not be a fraud. But there is definitely more loss because the total margin we generate from a transaction is lower than the actual plan amount. So so let's talk about different methods. There are semi-supervised techniques where we mark certain fraud and we confirm certain fraud and we understand what is the information gain through those transactions. Other important classification is how fast a fraud can be detected, how fast we can identify, and what are the types of fraud we can identify, whether they are done real time or they are done in a batch method. Now, going back to various ways of stopping fraud, one of the ways is we can add all the fraudster or known fraudster in a backlist, and we block any other transaction which exactly matches with the pre-established fraud type. So you create a backlist, and then if there is a new transaction comes which looks very similar to the historical transaction, then we block all those transactions. Uh, then is supervised way of labeling. So you uh, uh, but the drawbacks of blacklists is that the fraudsters are always evolving and there is new modus operandi happening. So we're not able to the after some time the blacklist becomes outdated and we need to constantly refresh it. Another way is looking and generating features out of known fraudsters. So we use some supervised approaches to identify fraud. In that, we can use neural networks or support vector machines. So neural network and support vector machine by used by Gauss and Riley in 1994. There was Bars in 2003 used a multi-layer neural network with exponential trace memory to handle temporary dependency in video on demand log data. And Seda in 2002 proposed a fuzzy neural network on parallel machines to speed up the rule of production for computer specific or customer specific credit card fraud detection. And there are various support vector machine or neural network or Bayesian network algorithms used to identify and label fraud. Um, then there are also techniques used such as ADA boost and like using naive base and decision tree methods and nearest neighbor methods to identify fraud, but those are pretty slow and compared to the previous methods we discussed. But there are so many methods to to mention that I won't have the time to go through all the methods. But I would definitely encourage you to look at this paper by Clifton Fua to understand what are the various kinds of methods and supervised learning. Now let's look at a different technique, which is the hybrid technique, where you um, add on multiple supervised algorithms such as neural network, Bayesian network, and decision tree, and combine them together to and come up with more accurate models which have lower biases. So, so this hybrid model is again a very sophisticated method, which could result in uh, you know more accurate predictions. So another kind of hybrid could be a combination of supervised and unsupervised. As you said, we don't have label data available to us all the time. So using unsupervised algorithms and telecommunication domain can help us, figure out what are the signatures and telecom account signatures, which are usually daily updated, and we use those uh, uh, clusters to identify them as fraud, and then we can use supervised learning on top of that to predict our fraudulent activities. Finally, we come to semi-supervised approaches with only legal, and there is unsupervised algorithms as well. So, in semi-supervised approaches with only legal or non-fraud data, it's a it's a novel fraud detection method. It has 5 steps. First, it's generate a randomly associated rules, which is a priori list, which is similar. List of all the fraudster which are very similar, and then apply it to the legit transaction. If anything which does apply to the legit transaction, remove those rules, and then you apply the remaining rules on the front end transaction in real time and see how well that rule is performing. And you can also modify do some random tiny mutations on our existing rules to check slight variations in the rules we have generated. And finally, we keep the rules which are performing well and prune or remove the rules which are not performing well. In unsupervised approaches, we do link analysis or graph mining, this method is used primarily in anti-terrorism or law enforcement and the security agencies. And they are fairly underrated, but they are pretty useful in finding out a relationship between different fraudsters. Because what we have observed is fraudsters do form syndicates, and there are similar patterns appearing. So it could be the same person doing multiple fraudulent transactions, or it could be a group of people who would use this, who have found out a loophole in the system and are trying to exploit that. Um, So with this was the mostly the kind of techniques which are used in fraud detection, but these techniques can be also applied in terrorism detection or can be also applied in spam detection. So this is an interesting paper if you want to get more into it, but broadly classifying these were the techniques used by fraudsters to exploit, and now you have a basic understanding of various methods to identify and filter fraud. Hope you enjoyed it. Stay tuned and come back for more. And if you like this, just hit a like on this video and subscribe to my Catch the Crook channel. Thanks.